Okay, so new chapter, chapter 5, electromagnetic induction. So 5.1, magnetic flux. 5.1a, define and use magnetic flux. And 5.1b, use magnetic flux linkage. Okay, look at magnetic flux. Magnetic flux is defined as the scalar product between the magnetic flux density B with the vector of area A. Mathematically, we can rewrite as flux phi is equal to B dot A, whereas the dot product considered as BA cos theta. Flux is a magnetic flux. Phi, the symbol of phi is magnetic flux. B is the magnitude of the magnetic flux density. A is the area of the coil, and theta is the angle between vector area A and B. It's a scalar quantity and its unit is Weber or Tesla meter square. Okay, we consider that uniform magnetic field B passing through the surface area of a single turn coil shown in figure below. So, the angle between vector area A and B is you define here. Cos theta, theta here means that the angle between vector area A and B. So, vector area A ni always perpendicular to the surface. If your surface like this, and then the vector area is 90 degree to the surface. Okay, jadi kita punya angle tu awak mesti faham angle antara normal to the surface dengan B. Okay, bukan plane of the coil dengan B. No, dia mesti vector area A dengan B. Okay, bukan plane dengan B. Jadi awak tak boleh tengok yang colour kuning ni lah. Okay, pastikan you tahu macam mana nak cari angle between B and A. Alright, note that the direction of vector A is always perpendicular or normal to the surface area. Okay, so surface area, normal to surface area itu adalah vector area A, di mana dia adalah angle antara vector area A dengan B yang you kena tahu to substitute in the formula of magnetic flux. Okay, magnetic flux is proportional to the number of field line passing through the area. Lagi banyak number of magnetic field line pass through the surface area, so maksudnya lagi tinggilah dia punya magnetic flux. Okay, magnetic field line yang masuk dalam surface lagi banyak, maka banyaklah dia punya magnetic flux. Okay, yang tu yang you kena faham. Ini kita panggil dia punya define secara kasar lah. Lagi jelas korang akan nampak. Okay, so contoh macam ni. If let's say now I have a coil dan saya nak gerakkan coil towards bar magnet, coil towards bar magnet. So this coil, okay, nampak saya gerak. Okay, let's say lah dia duduk dekat sini. So means that what will happen to this coil? So dia tidak akan merasai apa-apa. Jadi dekat sini kita boleh consider that magnetic flux dia initially, okay, at position 1 lah. Okay, 0 Weber lah. Sebab because no number of field line that pass through the surface area coil tersebut. Okay, let's say I move the coil move forward lah towards the bar magnet. Okay, so nampak tak? Dan nampak ada 3 magnetic field line pass through the surface area of coil. Jadi dia akan mengalami magnetic flux lah. Okay, magnetic flux 2 sama dengan contohlah 3 Weber. Contoh I tak tahu berapa, I assume. Sebab 3 line yang masuk surface. Macam tu lah. Alright, so next kita move lagi ke depan. So, position yang ketiga, flux 3 is equal to 5 Weber. So, as conclusion, you boleh cakap dekat sini, semakin mendekati or how many, maksudnya more electric field line and more magnetic field line pass through the surface area is more or increase dia punya magnetic flux. Okay, dalam arti kata kalau lagi banyak line masuk surface, so tinggilah dia punya magnetic flux. Okay, so let's try this. Okay, soalan ni tak ada kiraan, just nak tunjuk you macam mana nak tahu angle tu di mana. Okay, calculate the magnetic flux when the surface of the coil make an angle of 30 to the magnetic field. baca ayat tu kena betul-betul, because dia kata surface of the coil make an angle of 30 to the magnetic field. This is direction of magnetic field. And then the surface of the coil. This is surface of the coil make an angle with B with 30 degree. Nampak saya lukis 30 degree kat situ. But formula magnetic flux is equal to BA cos theta. So theta here means that the angle between vector area A and B. So you kena cari dulu vector area A kat mana. So vector area A always perpendicular to the surface of the coil. So bila saya lukis A dekat sini, jadi untuk masuk angle di sini, so you have to know what the angle between vector area A and this B. So 90 degree minus 30, you get 60 degree. Okay, macam itulah. Alright, so next, okay, we have the conducting circular loop of radius 25 ohm meter is placed in XY plane, uniform magnetic field of 0.36 Tesla. That point in the positive Z direction, the same direction as the normal to the plane. So maksudnya dekat sini dah bagi tahu yang direction of B duduk dekat positive Z. So I lukis macam ni lah. Okay, first you lukis dulu komponen X, Y, Z, and then plane ni duduk dekat XY plane. So I dah lukis lah loop ni dekat XY plane. And then direction B, same direction as the positive Z. So positive Z dekat sini. So I lukis macam ni. And then dia cakap juga same direction as the normal to the plane. Normal to the plane is 90 degree to the plane adalah vector area A. Okay. So next the question asks to calculate the magnetic flux through the loop. Magnetic flux through the loop. So kita akan guna gambaran you kena ambil daripada side tepi lah. Mata you kat sini, saya akan nampak bentuk dia macam ni. Okay, as you can see here that the coil, okay, and then 90 degree to the coil is vector area A and B is parallel. Okay, parallel maksudnya 0 degree. Okay, so kira je lah. Okay, BA cos theta, substitute value of B, and area, you kena tahu area dia adalah circular loop. So dia bagi you radius. So formula for radius, area for circular loop is pi r square. Pi r square. And then cos 0. So we get 0.071 Weber. Okay, next. Suppose that the loop is rotate clockwise around the x-axis, so the normal direction now point at 45 degree angle with respect to the z-axis. Calculate the new magnetic flux through the loop. Okay, sekarang ni benda ni try to rotate component x, tapi bentuk dia jadi pada angle 45 degree. So saya sengitkan benda ni pada angle 45 degree. So untuk 45 degree tak ada masalah, sebab angle 45 even you duduk sebelah sana ke sebelah sini ke still lagi 45. Tapi kalau angle dia bukan 45 tu yang kita takut, pelajar tak tahu kat mana nak cari angle sebenarnya. Okay, so kena faham soalan lah. So now the angle vector area A and B is 45 degree. So substitute the value and then you will get the magnetic flux when angle is 45 degree is 0.05 Weber. Okay, see what is the change due to the rotation of the loop. Okay, change of the flux is equal to negative 0.021 Weber. Okay. Alright, change ni selalunya kalau dalam formula kita akan ambil final minus initial. Okay, from previous class we learn about magnetic flux. Okay, now what is a magnetic flux linkage? Okay, magnetic flux linkage for a coil of n turns, each turn will has a magnetic flux of BA cos theta through it. Therefore, so magnetic flux linkage you can consider as number of turns times with magnetic flux for one surface. Okay, so contoh dia macam ni lah. We have solenoid or any coil with the several turns. Okay, so maksudnya you ada banyak surface. Okay, kalau you ada satu saja loop tak ada masalah. Tapi kalau more than one turns, so you kena consider semua. Jadi you kena dapatkan dia punya magnetic flux linkage lah. Okay, so maksudnya satu surface is BA cos theta, another surface pun is BA cos theta. So total of this surface adalah magnetic flux linkage. Okay, so ni adalah simbol magnetic flux linkage. So you also can use this one, phi with the capital L subscript. Capital L is equal to N flux. Okay, so kalau macam contoh yang ni, dia adalah 4 times magnetic flux lah. Itu adalah magnetic flux linkage. Okay. So next, a coil having an area of 8 cm square and 50 turns lie perpendicular to the magnetic field of 0.2 Tesla. If the magnetic flux density is steadily reduced to 0, taking 0.5 second, determine the initial magnetic flux linkage. So they said that the coil lies perpendicular. Coil lies perpendicular to the B. So lukisan ni macam ni lah. And then you know that vector area A always 90 degree to the surface. So ni adalah A and then B. Alright, so next awak tahulah angle between B and A is 0. Okay, magnetic flux linkage formula is N flux. So NAB cos theta or NBA cos theta is up to you. As long as you know that ialah AB cos theta for flux. Okay, N is 50 turns times with A. Okay, area here is 8 cm square. And then you have to change in SI unit into meter square. And then times with 0.2 B and cos 0. So we get 8 times 10 to the power of -3 Weber for magnetic flux linkage.